Okay, so this is Chapter 9, Section 2, and we're going to be looking at hyperbolas. Now, similar to ellipses in 9-1, we do have horizontal hyperbolas and vertical hyperbolas. This is an example of a horizontal hyperbola, an example of a vertical hyperbola, and we can look at the vertices here. These are our A values, so similar to how ellipses work, we have an A value that tells us our vertex. And then we can use this equation right here to find our foci. Now, different from an ellipse, our B values don't actually give us points on the graphs, but we will see on the next page how we use those B values to give us a little bit more detail in our graphs. This axis right here that the graph goes through, that's called our transverse axis, similarly here for the horizontal hyperbola. So let's go ahead and look at some examples here. It says find the vertices and locate the foci for the following hyperbolas with the given equations. So we're given this equation here, and it's asking us to locate the foci and the vertices. It's not asking us to graph, but that is going to be helpful for us. Now, because our x value is first, that's going to mean that this is a horizontal hyperbola. Now, let's look back at those equations for a second. Notice the difference here between the equations for an ellipse is now we have subtraction in the middle. Whichever variable is positive is going to determine whether this is a horizontal or vertical hyperbola. A and B, it doesn't matter which one is bigger anymore. A is always first, B is always second. Same over here. So the things that are changing now are where x and y are. Again, if x is positive, it's horizontal. If y is positive, it's vertical. So let's go back to the example we're looking at. Our x is first, so that tells me this is horizontal. And that means this is my A value. So A is going to equal 4 and B equals 3. And if it's horizontal, then this is my transverse axis. So this would be 1, 2, 3, 4. And that's one vertex. And there's the other vertex. And now I can find my my foci with c squared equals a squared plus b squared. Notice this is a different formula from an ellipse. So c squared equals 16 plus 9, which equals 25. So c equals 5. And then going out here, that's my focus. And that's my focus, 5 from the center. So it asked us to list those points. Let's go ahead and list them. My vertices were -4, 0, and 4, 0. My foci were -5, 0, and 5, 0. Okay. Moving on to the next example. We have y squared first now, so that tells that this is a vertical hyperbola. That means this is my a value and this is my b value. So a is equal to 3 and b is equal to 4. And I can go ahead and plot those points then. So we want to figure out where our foci are. We can figure out what our vertices are already. So we can go up 1, 2, 3, 4. Actually just 3. That's our vertex. And 1, 2, 3. That's our vertex. And then I can find my foci, which are going to be c squared equals a squared plus b squared, which is 9 plus 16. So c equals 5 again. So going up 5 gives me my focus. And we know what those points are now. So we have our vertex, which is at 0, 3, and 0, -3. And our foci, which are 0, 5, and 0, -5. And that's what they asked for. Now I'm going to go ahead and flip the page here. And now we can talk about that b value. I said we would look at that b value and how it affects our graph and how it changes what it looks like. Before we get into too much detail here, let's go ahead and look at one more example here. It says, find the standard form of the equation of a hyperbola with foci at 0 plus or minus 3 and vertices 0 plus or minus 2. Now to help us picture what this looks like, let's go ahead and just graph it really quick. 0 plus or minus 2 is our vertices, and then plus or minus 3 is our foci. And so what that tells me is that my C value is 3 and my A value is 2. Well, my center is at the origin, so I know it's going to be my center at the origin. We don't have to shift it at all. However, looking at the fact that I have a vertical transversal axis, that tells me that y squared is first, x squared is second. My A value we said was 2, so 2 squared is 4. But I need to find that B value. So we can use our formula, C squared equals A squared plus B squared. C squared is 9, A squared is 4, and B squared. So B squared is equal to 5. And I don't actually need to find B. I only need B squared. And so I have my equation now. All right, so let's go ahead and look at this graph down here, and I'm going to zoom in on it a little bit. Okay. So our B value here is going to allow us to draw this box. Now that tells us how high we're going on the non-transversal axis, and we're going to make a rectangle with those values, with our A and our B values. What that does is it tells us what these asymptotes are here, and it tells us how steep this curve is going to be, whether it's flatter, kind of like this one, or whether it's more narrow. Because we could have a hyperbola, just kind of drawing off to the side here, where we have these really steep hyperbolas, or we could have ones that were much flatter. And that box allows us to determine whether it's flatter or whether it's steeper. So back to what we were looking at. Now we can look at how to find the asymptotes through those boxes. So for drawing them, we use the box, but if you want to find the equation of those asymptotes, we have them right here, depending on whether it's horizontal or whether it's vertical. Okay. Now there's some steps at the bottom of this page for graphing hyperbolas. That's just to help you if you forget what to do and how to go about this. It's just there for your reference. Flipping the page. I'm going to zoom back out here. We can also look at hyperbolas if we shift it. So if our center is not at the origin, let's say the center is at HK, then we can use these formulas here, and they work very similarly to the ones we've already been doing where the center was at the origin, and it shifts just like what we saw in 9-1 with ellipses. So let's dive right into doing some examples. At the bottom here, we can see how our asymptotes will change when the center is not at the origin. This is something that you definitely want to know. So let's go ahead and graph an example here. So it says to graph and locate the foci of this equation, and it wants to know what the equation of the asymptotes are. Okay. So, seeing that x is first, we know this is horizontal. And then my A value is obviously 5, my B value is 4. So let's go ahead and plot those points. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And it's horizontal, my vertices are here. And my co-vertices, I'm just going to put a little line there for myself to remember that that's where they're at. I'll just put a point, I guess. Okay. And that's going to allow me to draw this box. Now, I usually do this with a highlighter so that it kind of stands out and is a little bit different than the rest of the equation. So there's my box. We know that this is horizontal here. And it wants to know the foci as well, so c squared equals 25 plus 16, and that's going to be 41. So c equals the square root of 41, which is about 6.4. Okay. So that helps us figure out where our foci are. They're out 6.4 from the center. And now we can go ahead and draw these asymptotes through the corners of the box. So that's one asymptote, and that's the other. And that tells us how steep this curve is going to be. So here's this side, and here's this side. And we can go ahead and write the equations of those asymptotes. And because this is a horizontal hyperbola, we have our b over a. And those are the equations of our asymptotes. This is up 4 over 5, and that's the slant of this asymptote, and up 4 over 5 here. So there's our first graph. Let's go ahead and flip the page and do a few more examples. So now we have a hyperbola that is no longer having the center at the origin. Okay, so we want to be careful about this graph. Okay, and let's go ahead and state what our center is right away. Our center is going to be at 2, 3. And so we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So our center is at 2, 3. Okay, that's our center. Our A value, this is a horizontal. Our A value is 4 and our B value is 3. So we're going out 4 each direction, to the right and to the left, over 1, 2, 3, 4. And over 4 this way. Those are our vertices. And then we can go up 3 and down 3 for our co-vertices, or these points that help us draw our box. And I'm going to go ahead and just lightly sketch that box. And we can also find our c value. C squared equals 16 plus 9. So c is equal to 5. So we can go out that many for our vertex here as well, or for our foci. Okay. And now we have enough to draw our graph. So I'm going to go ahead and draw my asymptotes. And the curve of my graph. And there we go. That's our graph. We have our center, our foci are at, let's see, that's -2, 3. And, oops, I think that's -4, 3. Or -3, 3. And our other foci is at 7, 3. And then our center, we said, was at 2, 3. And our vertices are at 6, 3, and -2, 3. Now, we also need to write our asymptotes, and that's using the equation on the previous page. So, our asymptotes, the equation for our asymptote, it's going to be y minus, using our center, the y value, 3, equals plus or minus. And then we've got our b over a, and that's 3/4, and x minus 2. And we'll stop there for this one.